Yeah, as Sumit told, right? So you have so many components you use to deliver your application, and then you use it in, like for example, you use SCM. I mean, a source code. You have a kind of a GitHub. You use something called a builder. You use something called a test framework, and there are so many things you use to get your code built, and then you hand it over to your maybe you do it by yourself. Then you hand it to your colleague or maybe your QA team, and then it passes from that QA team and it goes to production. So these particular chain, and then and tying all these tools together to get continuous outputs and integrating this is what I think we are trying to show today. And yeah, so maybe we'll be starting with the demo. So we don't have much slides on today. We are mostly focusing on demo, and then later giving some like takeaways, like take your products or take something which you can actually practice, and then how easily you can get your tools up and then attach them and get it working. So maybe I think so, Sumit, we can go ahead and start the demo. Over to you.
Sure. Thanks. Yeah, so let me share my screen. You let me know once it's visible to you, and then we'll directly pitch into the demo. So
Yeah,
I'll
Sumit,
just. Mhm.
so one more thing is like we before giving like so it is also good to give them a small brief on every tool and technology which we are going to use in this
Yes.
particular. Yeah,
Yeah.
that will be really great.
Yeah. Yes. So when we talk about CI, generally there is always a CI server or a CI manager who performs your continuous integration all the time. And there was a time, I think most of you people would have heard Jenkins before any other CI servers. But there are a lot of people out, a lot of tools out there, and what these tools do is they allow us to configure our continuous integration pipeline. And nowadays we are getting the tools little bit more what to say a little bit more evolved, that all the things you need for your continuous integrations are available at one place. Before, it used to be mostly a Jenkins doing this continuous integration for us, but code was stored somewhere else. And then after our tests, the what to say the output or the artifacts used to store somewhere else. So there are tools available, as I said, Jenkins, one of the famous CI tool, and then now we have something called Azure DevOps, which also does continuous integration and continuous delivery for us, allows us to do that. Then we have GitHub. GitHub itself has become a CI tool now. It not only stores the code, it does all your CI and CD. And then we have GitLab, Travis CI, and Circle CI, and some more. So you name it, and there are tools. But all ultimately they do the same thing. They allow us to create pipelines using some pipeline as a code, and then we give some steps which we want to do in our continuous integration, like build, test, published artifacts, and things like that. And the same CI servers are also used for CD. So they are CI/CD both servers. So this is the tools introduction, and today we have two demos. So Shailesh will tell what he's showing and which tools he's showing. So I'm showing you CI, mostly everything in one place, which is GitHub. And yeah, so just before we start with CI, any questions on this tooling or integration of these toolings? If anyone wants to ask something, say something. Yeah. If not, then we'll directly pitch in. And if you want to interrupt me in between, please go ahead, and yeah, we'll discuss that and then start on the way. So the first thing when you do CI is for sure uh, in what to say in software world where we have source code. So the first thing comes is where do we store your source code? We call it a source code management or source control versioning tools, and Git is one of them. And in our case, the code itself is stored in GitHub, and you can also store it in any other tool which has the same capability. So that is first thing. The code is stored here. If I give a little bit introduction about the code, it's a simple Python code and it uses a Flask. It uses Flask to write one sample API, and that API is nothing but I can show you quickly. It just returns. It has a function, Fibonacci function, and when you call this API on slash calculate Fibonacci, and you pass a parameter called n, and then whatever number you give, it returns you the Fibonacci number for that argument. So the code is as simple as that. But yeah, but then now to follow CI and do CI on our code, obviously I had to write test and different types of test. So first one is unit test. So as I showed you previously, there was a function Fibonacci which was returning the nth Fibonacci number. So obviously, since that's a function, I wrote a unit test here to test the same function, and then I call the function and then pass an argument, and then I see if it's returning the proper argument or not. And then this is unit test, and there are some other tests as well, like integration test, which normally don't call the function, so don't test the function. They test the API endpoint. So they call API endpoint and they test if it's returning the proper status code and proper value. What if there's a wrong value entered, then you get a proper error message and things like that. So so the code is written in Python using Flask. The tests are also written in Python using PyTest, and it's just a sample code to reproduce what we want to do with it. And then yeah, so that's all for the code. And then I have a Dockerfile. So the use cases that I built this code in Python, mostly there's nothing like you can build a code. So I just test the code. And finally, I package it as a Docker image, and so that I can store it somewhere. And finally, I can, use it in my CD, which we'll talk later on. But yeah, so that's the how the flow is. And yeah, so this is how my Dockerfile looks like. We had discussed once previously that multi-stage Dockerfile. If any one of you are missing that, we can still discuss it again. So in Docker, what we do is we use a base image, and that base image in this case should have the tools which I require to build my source code. So in this case, I have a Python image, and I give it a name as base so that I can refer it wherever I want as base. And then on top of that, I add a requirement.txt. So requirement.txt is nothing but all the dependencies my code has. So in my case, it's Flask and GUnicorn. So these are the Python modules which I want my app during the testing and then finally packaging it. So, okay, since I don't want to switch back and forth, let me open a new tab. So we do that. So the first step is we take the tools or the base image, which has things for us for our code to be able to build there. Then the next step is we download all the dependencies, and this process is followed in any language you are doing. So you are doing a C Sharp, C++, Java, any code base you gonna do continuous integration, or if you're doing a build, you will go through this process, right? You in case of Java, you will install JDK because that's a required tooling. In C Sharp, you will mostly have .NET. So you will have always the base dependencies or tools to build it. Then the next step you do is you download all the dependencies you have for your code, like modules or packages. So this is consists base image for this app, and then on that base image, then I refer this base thing as from base, and then I do the testing. So this part is testing for me. So what normally the testing is happening is, again, I install some modules which I need only for testing. So I have not put them in any requirement or text. I directly tell I want PyTest and I want PyLint. So PyLint is a tool which does a static code analysis. Uh, there are other tools like Sonar Cubes and other linting tools which do the similar stuff. And this is also a very much integral part of CI, because whenever we write code, we continuously run them through these static code analysis so that we know that, okay, our code is not using any vulnerable stuff, or our code is secure, we're not violating any best practices and things like this. And the idea is, so we do it continuously. So as soon as we check in a code, our CI runs and it tells, okay, you are doing something wrong, and it fails, so that we can fix it right there and there, realizing it later when it's in production, and then we find, oh, we missed some security related code and things like this. So in this case, I run pylint on all the star.py code in the repo, and then it tells me, okay, these are the things which are missing, and it gives a score. So it rates our code out of 10. This is where your code stands. And then after that, I finally run PyTest, and I tell that run the test which are in unit and which are in integration. There are some other tests which are API tests, which we normally don't run during this one, sorry, acceptance test, which we normally don't run during build, because these tests has to be run on a running application somewhere. So these are skipped here. They'll be pop up later on, but for now, yeah, this much. And when this tab is also green, then I know that, okay, my tests are green. And now finally I'll do is, again, I take my base image or the base stuff, and then I copy all the code from app folder to the app inside a container. I tell which port my app listens to, and then I finally give entry point. And finally, this image will be packed as one final image, and then I'll be pushing it somewhere uh, in a Docker registry so that I can use it later in CD. Okay, so any questions still here? Any thought? Anything which I missed in Dockerfile?
No, I think it's good.
And perfect. The other thing is, like I'm doing testing in Dockerfile itself. I'm downloading dependencies in Dockerfile, and then finally packing. You can also do it outside. So like when you're running CD, I do it in Dockerfile itself, but you can do it outside of Dockerfile, in the sense, in the CI steps itself, we can do like, let's download all the dependency, let's test our code, and then maybe leave only this part in Dockerfile, that after the testing, we just put the code we want, and this all these steps we can do in our CI. So that also I'll show where these steps can be moved if you really like to not do them in Docker. The benefit doing here is the dependencies come along the way, and I don't have to install them or have it on my CI agent. Yeah, one more thing which I missed and want to talk about now. We talked about CI server, but when we do the CI and we run all this task or this build, this all runs on an agent. So this server has a backend agent which has all this capability or tooling to do all this tasks for us. So what this server does when we run the CI, it assigns these jobs to that agent, and that agent executes this. And then you can have agents like Windows, Linux, Ubuntu, all kind of agents you can have for the server. So this is how my Docker file looked like, and now finally we can go that how the CI pipeline or the CI code looks like. So it's written in YAML. GitHub supports, in GitHub they are called workflows, and then I have a file called YAML, but it's doing same thing for us, continuous integration. So let's do it step by step. So I just give it a name. My CI name is Docker build. That's fine. Then the next step is on. On means when this CI will run. So this is like a trigger point. So I am telling it that whenever there's a push, means whenever there's a new code pushed into master branch, or the code is pushed with a tag. If you know that you can tag your commits in Git. So in these two conditions, I want to, if these two conditions are there, or these two tags, or a new commit on master is pushed, then it will run. Apart from that, there is also a trigger point called pull request. So if I create pull request on master, so normally what happens, uh, it's a best practice is that no one allows to directly do a code check-in into master. So mostly people follow this practice that you create your own private branch, you keep your code there, and once you have tested it, you will create a pull request to merge it to master. And then someone reviews your pull request, sees, okay, everything looks fine, and then you push it to master. So in this case, as soon as you create a pull request with the target master, the CI also will run, because as we said, right, when we want to test our code before putting it into the master branch, we want to run this build test and all that, and then we are sure that, okay, the code is compatible, everything is running green, then only we merge it into master. So these are trigger points which this CI or this pipeline runs or gets started on. Then there's a variable, it's like a normal coding variable. So this, I have defined a variable with a value, and this variable I'll be using it in the steps below. And then, yeah, and then we have something called jobs. So jobs are like a set of tasks which you want to run on one agent, or which one you want to define it as like a step of tasks which you want to do it together. And then maybe you can say you can have build as one job, and then running the test as another job, and then pushing it or storing in Artifactory as another job. Uh, why? And when you create a job, you tell which this job will be running on which agent for you. So in my case, I have only one job. If you see, everything is under one job, and the job name is this build, test, and push, and this runs on a agent called Ubuntu latest. So this is provided by GitHub itself. They are managed by GitHub, so I don't have to do much. The good thing is in this agent, like mostly I'll be using Docker, and so Docker is available in this. And also we can create our own custom agents, and we can attach to our CI server, and then we can run jobs on those specific agents. Okay, and yeah, so in each job I have some steps. So in my case, I have a step that check out the code, get the code from the repo, then do a Docker build. During Docker build, it should refer to the Dockerfile, create a tag, and then I have something additional which I have not showed you is after the build, I run some test using Docker Compose. So these are the tests which I mostly referring that time, which are in acceptance test. So what I do normally is, okay, let me show the Docker Compose file. Yeah, so the test looks like this anyway, if you are interested. So the tests are like any other API test, the base URL, and then the path, argument, status code should be like this, the return JSON value should be like this, and I run them using Docker Compose. So this is how the Compose file looks like. So this is the base image or the image we are building. I'm not building it from here. I'm building it in this way, Docker build. And the image name, what I've given is Fibonacci Flask, should be the same here. But this is the part where I run test. So what I do is, if you know the Docker Compose can start your container, so I tell that run this service, SUT, system under test service, which also uses a Python base image and gets a variable of this app, which is this variable, and then it runs, it downloads the dependency and runs PyTest on under test. Under test is this volume mounted I have done. So all my test under test slash acceptance here where it is. Okay, let me open another tab. So all the test under test acceptance. Yeah. So this directory is mounted as slash test in a container here, and then I'm running all this test. So what apparently it does is my Docker build was done here. Yeah. One sec. Yes. Yeah. So my Docker build was done. That means I have a Docker image ready with me. And now this Docker Compose does is where is Docker Compose? Yeah. So Docker Compose does is it starts this as a service app and gives this URL here as app port 80 and then runs my test. So that means whatever I'm starting image, it's available as a service. and then I run my test on this. So I run these tests to make sure that whatever the Docker build output, which is a Docker image, when I run that Docker image, it performs how my tests are written. So means I get to test not only the code which runs during Docker build. Once the Docker image is built, I want to test the Docker image itself, that it's performing how it should perform. And so to do that, I use Docker Compose, and I say Docker Compose file you use. And once it runs the test, it will keep this exit status in a exit code variable, and then it uses a command Docker Compose down to remove all the things it created during this. And finally, if the exit code was and then it exits with the exit code, and if the tests were failed, then it will exit with the failed exit code, and then the pipeline will stop right there. And so this is one thing, build and test. And now if that also goes green, then we know that, okay, my code ran successfully. All the tests were green. Then I tested on Docker image itself. That is also green perfectly well. Now the only part is to push this image. So for that, I do login to the registry using this step. Excuse me. So there I use some system variables. In this case, it's secret.github token and github.actor. So these are the variables which are already available in the CI because of CI server. So if you see here, I have not defined any variable like that. I have only defined one variable. So these are called predefined or already available variables due to your CI server. If you're using any other CI server like Jenkins or something else, you will have another list of those variables. So if you just Google, say, Jenkins pipeline variables, you will get a list. So similarly, these are the variables which I'm using to get the token and to do the login. After that, there's these code you can ignore. It's all does is it finally uh, it the checks if there is a tag, changes everything if something is in uppercase, lowercase, because Docker doesn't allow uppercase and things like that. But finally, what it does is it takes the image ID and the version. In my case, if it's master, it will be latest. And whatever I have imaged, built a bow with this tag, image name here, and it will tag it with another name, which is my ID and the version. And then the final thing is, since everything went green, I'll just push this image. So this is how the whole thing or the steps are defined. And once it runs, it will push a package here. So in my case, it's the package is pushed here. So this is the package which was pushed. So this was mostly the theory or the code already written is defined. But in real scenario, let's do another check-in to this code and see, how, as we said, if I create a pull request or I push to master, it should run this pipeline again. So for that, uh, I'll go to, I have checked out this repo in my local. I'll use that and I'll push a change, and then let's see if it really triggers a CI for us. So, mhm. I'm really sorry if someone is asking a question or just background noise. If you're asking question, please be a little loud so that I can hear you. Yes, so let's ignore whatever we have, blah, blah, blah. Okay, so first thing I'll do is git checkout master, and then I'll do git pull -r. Oh, my mistake. So this is to do normally every time since there'll be in a normal scenario, there'll be multiple people working on one Git repo and checking in code. So it's a good practice that every time before you start doing something, you just pull the latest code. So I did that, and now say I'll create a new branch. I'll say git checkout -b. -b means it'll create a new branch, and I'll give the name now. Say test branch. Just a sec. I'll mute everyone. Yeah. Please unmute yourself if you have any questions along the way. And now, so on a new branch, I do git status. Everything is up to date. And now let's do some check-in. So the safest place to do any check, break anything is readme.md file. And what to do? Okay, I'll just remove one new line. So I'll save it. Now if I see here, I see there is a change in the readme. I can see it here as well that this was modified. Now I'll commit it. So I'll do git add dot all the changes, git commit -m for message, and I'll say removed an extra line in readme. Yeah, and then let's push it. Git push. Since this branch is not available on the server, I have to set a origin upstream. Sorry. So now this new code is pushed into a branch called test branch. Let's see. So here it says test branch has recently pushed the code. And now, like a normal developer, I can create a pull request. So I want to say is that I have test branch and I want to push this code into master. So, and then I can give the heading of PR, I can write comments. So this is mainly what you write here is for the reviewer who is reviewing your pull request can read all your comments, can see all your code changes, and then can approve or reject your pull request. So in my case, I'm not, since I'm only the approver, I'm not going to write any description. And so this is how the pull request looks now. And if you see, there's already one check started for this. So now I'm a reviewer and I know that, okay, there's a CI running for this pull request. And if it is green, then only I will approve it because I know that, okay, the CI would have run all the tests. Along the way, I'll check obviously what commit it is, what code it is, but the one of the major decision will be if the CI is green or not, and then accordingly I'll approve this PR or not. So since you know that it shows there's something called triggered, let's see how where it is. So in GitHub it will be in actions. So if you go in actions, see there's already something triggered. And this is the same thing which I explained you earlier, that it will run all the steps which I had defined in that YAML file. So it will do the Docker build, it will run all the tests. And in this case, it's not running on master. So my guess is it should not push it because this is from a private branch and the aim for this was only to run the test and not to push the changes to uh, the directory because that should happen only from the main branch, which is master. So if you see, we can go and see the logs. It checked out all the code. It did a build. It did a build, and build also ran lint for us. So if you see here, this is output of Docker lint. It says my code is missing something. It's missing a module doc string. It's not following some snack case naming style, and then something else. And finally, it tells that okay, my code is rated 6.97 out of 10. And then I can decide. In my case, I'm allowing it to go further, but based on the criteria, we can set that okay, if your code score is less than 9, don't allow it and stop it right there. That also can be done. But in my case, I'm allowing it. After that, it runs all the tests. As we said before, 33% and finally 100%. All the 3 test cases were passed. And finally, the Docker image was created with this tag. And then in the next stage, I do is I use this image to run the test on top of this image. That is done in this case, run test. And here you will see that, okay, I ran the test which were part of acceptance, and both the tests were green, everything is 100%, and then finally it cleans it up. So that means everything went green. It skipped these two steps because this was a pull request, so that I don't want to push the changes because they are not in master, they are on a pull request. And the job is completed. So if you see here, it's green. And now if I go back to my pull request, let's go back. Yeah, here it is, pull request. I click on here and it already shows me that the check which I had put is successful. And me being a reviewer, I know that, okay, all my tests are passed, everything looks good. Then I'm ready to merge it to master. So this pull request is completed now and the changes are pushed to master. So if I go back and see in master, it shows me that there was a pull request merged 10 seconds ago. And again, it started another CI because now the changes are just pushed to master. And this time it will not skip these two steps because now it's running on master and I want to build it, test it, and finally publish the artifact somewhere so that it can be used. Uh, until this runs, we can discuss about questions. I see there's someone has posted something. Okay, are you going to do pipeline build via Jenkins as well as today after SCM? Yeah, that is correct. So this was on GitHub, but Shailesh will be showing it on Jenkins. So any questions till now, guys? I'm going fast, slow. Any questions? If not, then as you see, this time it has pushed the image. And then this artifact is available for me in packages. So this completes the CI part. And if I would have been doing CD, please go ahead.
Yeah, Sumit, Shailesh here.
Yes,
Huh?
Alex. Yeah.
So I just wanted to understand that if it is how easy it is for others to try out. For example, you like is your whatever code you wrote, is it for configuration for this application? Is it public or people can try out?
Yes. So this repo is completely public. If you want, I can copy and paste this URL into chat. Yeah. If you have a GitHub account, you can just fork it from my repo and you can just run the workflow directly. But I would not advise you to do the same thing because it's the easiest step you can do. But then you can maybe modify things a little bit. And if you want to add more tests or want to write some other API, so try to do some changes and see how the CI works. But just to start with, it's very easy. Just fork it and run your actions. It will right away get you the things. And yeah, so CI is complete. And in this case, the packages are available here. And if I would have been doing CT, I would have been picking this package and deploying it wherever I need. But in today's session, since we are covering till CI, this is how it is. Okay, so if no
On
questions,
ca.am,
yes.
question
Okay. Yeah, please ask.
or it varies from one CI tool to another CI tool.
Yeah, it will vary from one CI tool to another CI tool. Why? Because these instructions written in this CI are specific to the server you are running on. So in my case, if you
Okay.
say push these jobs, mostly everyone is trying to follow the same strategy that you have jobs, you have steps. But then I say, for example, this action, I'm saying action checkout, or I'm saying, oh, rest all will be okay because they are written directly in bash. But even this thing, run. So run is kind of like a plugin or a task. Checkout is also a task. So these tasks will be different in another CI altogether. Just to give a glimpse, I was doing today on Azure DevOps. It's not yet ready, but in Azure DevOps, my YAML will look like this. So if you see, it has changed trigger instead of on. Here I had on. If you see here, on push. Here I have something called trigger on branch master, and my tasks are changed in little bit. Here I have script. Here I had run.
Yeah.
But more of the same. It is similar, and it will not be very difficult to switch from one CI to another CI. The good thing is all I'm doing in CI is Docker build and Docker compose stuff, generic wherever you're running it, and everything else is in my Docker file itself. So it's very easy to move from one server to another server.
So the moment you commit the code, this ci.ml kicks in and it knows that there's a code change. So it will do the
Yes,
actions what you do. Okay.
exactly. So in a normal, in my where I work in my company also, we follow the same process what I showed you guys. I create a private branch, I push my changes there, and once I create a pull request, my CI kicks in, it runs all the test cases on my private branch, and then the guy who is reviewing my PR will know that okay, all the tests are green, and then if he has nothing to comment, he'll just complete it. He'll approve my PR and I'll complete it. If the CI is failed, tests are failed in between, it will not allow me to merge the changes to master. So for sure, I have to make sure that all the test and CI runs green to merge to the master. So that is the normal practice followed by mostly everywhere. So if you see any open source project also, people are doing the same. They'll fork any repo, they'll create a pull request, and then if everything is green, then only it will go on.
Yeah, hi, Sumit. Vijay here.
Yeah, Vijay, please.
Yeah, okay. So is there any webhook configured over here?
No, because everything is in the same. I think GitHub has internally have a webhook for the actions. If I would have been using another CI server, then that CI server has to talk to GitHub to understand, okay, there is a new code change pushed right now. But since my CI is running rightly on the GitHub workflows, I think it's internally done. So yeah. So GitHub
Okay.
gets to know automatically when I do a code change. The actions gets to know automatically that there's a code change happened. But in this case, for example, if I would have been running it on another CI server, in my case Azure DevOps, then obviously there is a webhook connected to my repo, so that when there is a code change, because code change is happening in GitHub, right?
Right.
So
Yeah.
how would Azure DevOps will get to know that, okay, there is a code change? So this guy will have a webhook. GitHub will have a webhook to tell Azure DevOps that, okay, there is a code change, please run your CI. But in this case, there is no webhook.
Okay. Okay.
Or
Got it.
if it is there, it's internal somewhere. Yeah.
Right. In case of any other external tools like Jenkins, we would have configured a webhook.
You have to configure a webhook here because your code has to tell your CI server that, okay, hey, there is a new change, please run the job.
Right. So, webhook, we can configure at the branch level and as well as repository. Whereas if in case we have multiple folders, the repository will be the one, and we have multiple folders where we have the code and the Docker file and the Jenkins file into it. So in
Yes.
that case, any idea how are we going to configure the webhook?
Okay. So as far as I remember, the webhooks are always on repo level. I think in my settings, they'll be there somewhere.
Right.
Yeah. But what happens is when you configure this webhook in your trigger, wherever you have your CI code, right? In my case, my CI is in here. In my Azure DevOps, my CI is here. So the webhook for each change, it will inform your CI server that there is a change. But then my CI pipeline can decide that do I want to run it if the change was on master or there was a change on tag. I think there is another thing called folders. I'm not sure, but something like that. And then I can tell my CI server that run my CI if there is a code change on that path specific. So the webhook will give all the information to your CI server, no matter where it is. So it's mostly on repo level, as I showed you here, where it is. Wow, I just closed it. Yeah, so if you go to settings, settings are on repo level and webhook also will be on repo level. But then your CI server gets to decide for which information your webhook is passing you, you want to run it or you want to skip it.
Okay, so without disturbing any other folders to run automatically. So if we have like Jenkins pipeline configured for different folders respectively, so we just have to trigger if there is any change in one particular folder and the respective pipeline in a Jenkins or any other CI servers. So
Yes.
in that case, like how exactly we gonna configure the webhook from GitHub
So,
perspective?
Vijay, just to add on to your question, so
Mhm.
that's actually a folder-based checkout you're talking about, I believe.
Right, right.
Right? Yeah, yeah. So actually, yeah, you can do a folder-based checkout as well. That's altogether a different concept altogether. And like when you talk about the webhooks, right? So when you configure this any repo with a multi-branch pipeline, then you don't need to configure a webhook. So you just need to place your GitHub credentials just to talk to the GitHub. And if you configure this your repository as a multi-branch pipeline in your Jenkins project, then it automatically kicks in. Like let's say if you do a checkout for a master branch or whatever the branch you like, and you want to see those changes, it automatically kicks in your pipeline. So there's no need of configuration of webhook externally
Yeah,
in
that's
the
in branch
multi-branch.
level.
Yeah.
So if we have like one common repository and multiple folders
Yes.
inside it.
In the Jenkins pipeline itself, you need to tell actually. In the Jenkins pipeline, there are some stages, right? So in the stages, you need to mention it is a folder-based checkout, and you just need to mention the few codes for that. Few code lines you need to mention, like branching strategy and all.
Okay.
You need to put a when conditions and all, and you just need to mention whatever the changes. Let's say a folder A has some changes, then do this checkout like
Yeah.
that. You need to mention in your Jenkins pipeline.
Okay. Okay. Got it. Got it.
Yeah.
Thank you.
So
Yeah.
as you see, you have some trigger events here, but I don't know how good it is to trigger only for one. Means it depends case on case, and I also don't know if there is a trigger event only for that specific folder, or you can just directly choose send me everything, and on your server level, CI server level, you decide that for each event what you want to do, or you can filter out here, but I don't think so on folder level there is any filter. The max it has is if a branch or a tag is created, it will give you an event. Yeah,
Right.
yes.
Okay.
And
Thank you.
then, so you have to filter out at the server level. Perfect. Okay, Shailesh, I think we are running a little bit out of time. So if I'll anyway stop sharing. And if you have a question, we can still continue, or Shailesh can show us the another demo. All well? Shailesh, are you there? Let me just check in.
I think his audio got disconnected, probably.
Oh, okay. So let's hope he joins back as soon as possible. Until then, we can continue this discussion.
In the meanwhile, you can come up with any questions, guys. If you have any questions regarding the demo, what Sumit has given so far, questions are welcome.
Okay, if no questions, then fine. But as I said earlier, you can follow this process in any uh, uh, code you are using, like Python, Java, C, C++, C Sharp, or anything for that matter. And yeah, and sometimes it's also followed in hardware industry. So they also have some pipelines, obviously not pipelines like in Jenkins, but some automated pipelines in their factories, and they do similar things that when they have a new product or whatever, they have that pipeline which tests, removes the dummy things on the way, and finally tests out.
Hello.
Yeah. Hi, Shailesh.
Hey, I sorry, man.
No problem. So can you start? Can we start with your demo? Is
Yeah,
your setup available?
yeah, it is available. Just give me a moment.
Perfect.
I'll connect from my laptop too.
Mhm.
Sumit,
Yes.
yeah, can you show us example on how do we clone the in a repository
Yeah. Yeah. Why
if
not?
you have?
Yes. Start sharing. Since I cannot clone my own repo, I can show you how we can clone some
Yeah.
other repo and start doing it. Do you see my screen?
Yes. Yes.
Yeah. Okay. Let's try something from Kubernetes. Yeah. So Kubernetes is an organization, has so many repos. Let's go to say examples, and uh, I'll write somewhere. I'll have okay. The UI is a little bit changed, but yeah. So here I have an option fork your own copy of it. So I can just say fork, and I can fork it to my own. And after that, yeah. So if you see now, it's my username / example. So now it has become my repo, and all the changes I'll do, for example, in this case, actions. This guy doesn't have any actions set up, but if you fork my repo, then you will have actions here because you have .github / ci.yaml. So in that case, you'll get that workflow, and you can directly trigger it, and then you can even start doing changes and all. And normally how people do this forking in GitHub is because then now I'll create a branch. I'll do all the changes I need, and I can create a pull request into the main branch, which is this Kubernetes example. So that's how people in open source they do. So if you see, there was a pull request created by someone, and it was merged. Or to be specific, sometime I also do things where it is Falco. So for example, there was a repo called Falco. I did some changes and I created a PR. Uh, okay, it doesn't show where it is, but yeah. So that's how in open source people work. They fork someone's repo, they and they contribute to it. They do some code changes, and then they create a pull request to the main repo, and then the same CI kicks in, and people approve your request, and then finally it gets merged to the main repo. And same can be done for the repo where I gave you demo. So that's how you can fork it.
Thank you.
All clear?
Yeah.
Perfect. Shailesh, are you ready?
Yeah, man. Let me share my screen.
Yeah, perfect. Awesome.
So please.
Shailesh.
Hello. Am I
Yes.
audible?
Yes, you are audible now.
And is my screen visible?
Not yet.
Okay. So maybe now.
No.
Let me rejoin from my laptop.
Uh-huh.
So till then, if anybody has any questions, maybe we can. I think so. You guys are already done with questions, right?
Let's wait. Sorry for the technical glitch.
Yeah. Just give me a moment. It's like. No, I think you guys should be able to see my screen.
Yes, we can see now.
Okay. So should I zoom out? Zoom out?
I think it's readable perfectly fine.
Is it readable? Yeah.
Yes.
Okay. So just to give you introduction, what I'm going to show today. So as Sumit already showed, right? So he gave you an explanation with GitHub and everything in at one place. So I am including so many different tools, and like for example, I'm using the CI server, Jenkins as a CI server, and I'm using a Jenkins pipeline, and there is this small code which I wrote yesterday, just to give you a look and feel of like what we are trying to do. And also, as I said, right, so it is very easy for you to download this and try it out. And at the end, you are going to get a Docker Hub image, which you can directly go ahead and pull in from here, this place. So this is the latest image which is being pushed over here. And yeah, before starting, what I'm going to show you what actually the application is. So this is the application. Maybe forgive me for the what do you call UI. I just tried to put so many things, and then this is how it looked. So it is a small event application where it's a Django application. I did it in Django because it is little easier to do in Django than maybe in Java. So here it is like you have your events, these particular events, and then this image has this version of your application. Okay, and one more thing before diving into the CI server Jenkins pipelines, I want to just show, just go ahead and add something over here. Maybe I just wanted to add one event demo. Maybe we can say CI basics tools, and then date you can put it for a minute. I think so. It is like this one, and then time it was like just a small example. You can put it over here. So speaker, I can say all of us. As of now, let's put this NA. and then save it. So if you go ahead and see, you should have one more column added over here. So we just wanted to understand. So for example, in this case, I added few data, and then just to give you a look and feel that this is small dynamic website, I made it. And then if you want to look at how it looks like, so this is where you can check. So there is an app called Meets, and then this app has a database. I'm using SQLite as a database, and then this is how you write it. So like maybe you can, if you want, you can go through it and then like understand what it is. And then if you want to know about how templates look like, there is a small index.html which I wrote it over here with some CSS. So this is where all things are coming from. This is your HTML, and this is your CSS. Okay, so at the end, for example, if you want to try it out, you just have to use this image, Docker image. So Docker pull OS group geeks CI demo, and the tag should be master_4, and you'll be all set to go. And at the end, I also will be showing easy way. You don't have to do anything from here. You just need to have Terraform installed, and then you just clone my repository, and then you just say Terraform init apply. Then you will be all set to have this code. And then later, if you want to like modify, you can modify. Yeah. So this is the code, and then there is a Jenkins. This is Jenkins. So if you guys want to have Jenkins running easily, maybe you can check out on YouTube. There is a video on Jenkins as a code. So you don't need anything. You just need a Docker install and I think Terraform. And if not Terraform, so you just need Terraform installed, and I think so you'll be all set. So go ahead and watch the video. Yeah. Okay, so this was like just a small introduction, what and all you need and how you will do it. So before going to like how we deploy this application, I'm like will not be talking on that. But for example, if you want to have a look and feel how it looks like, just with this Docker image, you can go ahead and do it. Maybe I'll be talking on this in later part of the section. So this is a Jenkins job, okay, and then there is one job. The build number is 4, and if you see on the Docker Hub, you have your tag as a master and as a build number. So master is a branch. It has created a tag with a branch and a build number. And then since it was successful, so it has published it on your Docker Hub. So when I'm not going to build it right here because it will take time. So maybe I can walk you through the logs. So what and all it is doing. Yeah, so if you want this Jenkins setup up and running, you can just go ahead and follow the instructions on Jenkins as a code. It's very easy. You just have to clone few things and then just run few commands, and you'll be all set. So yeah, when you see, right, so it is going to run on a node. So just trying to relate with what Sumit showed. So in that he had some agent, and that was taken care by GitHub. And in this case, you have to have your node agent, which is attached to your CI server. In this case, I have this Django node, and on that Django node, I am having all the pre-requirements. For example, Python, Django installed on it, so that I can do tests and then push the code into the Docker Hub. Sorry, into the Docker image and push it to Docker Hub. So when you see, right, so there are a few stages. When you see the first stage, so in the first stage, it is getting the latest. It is just checking what, and it is also getting you the latest commit messages, latest 5. And here, actually, I was trying to write the test code, but it was not working, so I didn't write it over here. Maybe when I show the Jenkins file, you'll get to know. So test. You have image built. So your image is built. As you can see, it is built with your branch name and your build number, and then these are things which is happening inside the image. And then at the end, you have a command which is starting your application. So after that, I'm just tagging it to this name. So it is mandatory to have like this. It is your registry name, registry name and repository name, and then your tag. And yeah, so after that, I'm just logging in. And here you can see, while if you want to log into Docker Hub, you need to pass the credentials. So one way I used this in very fast way is like just I stored that in JSON format and on that machine, which is like Docker, which is the node. Yeah, and after that, I'm pushing it to the master. So this is what my application is doing. And when I'm done with that, what I can do is I can come over here. I can clone this repo called DevOps for you, which is there on my GitHub, and then go to this particular folder. In this case, it is Terraform Docker CI demo. And when you just check, you can find a TF where you just need to mention the image name, image number, and then you just do Terraform apply. So you have your application like this. Cool. Okay, so to go a little more in detail, so when you see this repo, right? So in this repo, if you go in the main root folder, you can see there are two files. One is Dockerfile, another is Jenkins file. In Dockerfile, it's all same steps, which actually with few steps which is not there. It's the same step like getting the base image, installing the requirements, which is in requirements.txt. I have put it in rex.txt, and then adding the code inside a Dockerfile. Maybe we can have a look. So this is how my Dockerfile is looking like. It's very small. So it's doing these many things, making a directory and just adding that to .txt in that directory, making that as a work directory, and installing these essentials, and then adding the whole code from CI demo app to the project and changing the directory and then exposing a port and then running it. So this is what a Docker file is containing. And then when you talk about Jenkins file, I think this is the place where most of you are interested. So this is how it is written. So this is a Jenkins pipeline. When you say there are a few stages, so a stage is like checkout and test. In this stage, you are checking out the code. So when you just do checkout SCM without anything, it will clone your master branch of a repo which you have used here in the Jenkins. Maybe when I can show you when I just do configure to that job. And then there is a test. So you can run your test cases over here. You can have if conditions, and then you can have try catch according to your use. So it is very plain over here. Maybe you can add something which is actually fitting your situation. And then build the image and push to registry. So I'm just using a same command which is actually used to build an image, and then I'm using the branch So branch to get the branch from my GitHub. So in this case, I have actually mentioned in my Jenkins repository, Jenkins job. And this is the environment variable from where I can get the build number of the job. Then I'm tagging it and then I'm pushing it. So here, this is what it is here. And then when I go ahead and check, I configure this job. So there is a branch kind of stuff. There is a variable which I've defined as a branch, and then which I'm using inside the code. And this is the pipeline. In this pipeline, I have configured this to get the Jenkins file from this particular path, which is in root. So I think like anybody can use this pipeline directly use this URL, because there is no authentication required. Make sure you use HTTPS and then start running it. So it is as simple as that. And then small few tweaks is like I'm just using a discard out builds, and then I think so. If you go in detail about how you to use these all, and then how you can trigger emails and so many other things. So there is another way is like you add a hook. So in this case, there are different use cases, like the companies where there are so many developers, and then they want to have a nightly builds instead of having build trigger on every push or merge. So they want to have a time, and they want to have a timeline that everybody pushes their code in before this particular timeline, and then they have this particular job running at every night. And then after that, when they have something they give it to QA, and when the QA say like, this is fine, then they actually mark that as a stable build, and then they proceed to other stages. Okay, so this is how it looks like. Maybe I can trigger one more Jenkins build from here, and then we can discuss if you have any questions. And meantime, this will take a little time. So you go ahead and do build with parameters. From here, I think I already did it. So go to console output. You can get Jenkins as a code. You can get Docker as a code. So if you go ahead and check out my repo, if you don't have Docker installed, there is an Ansible I have written for Docker. There is a Terraform and Ansible written for. There is a Terraform written for Jenkins, and then there is also Terraform written for this application. So you just have to clone these particular repos. For example, maybe I can share after the question session that how you clone and then get it started. So all you have to have is Terraform installed. And if you're running Docker, you have to have Docker installed. So this is all I have. I wanted to cover it very fast because already we are out of time. And then I'm okay to take questions.
So Kailash, I have one question. So
Yeah, please.
this Django node is running as a container, or it's just altogether a VM or a Docker slave?
Yeah.
That
So
node,
in this
node.
case, it is good to have a Docker node as a slave, but
Yeah.
I have used Linux containers. So for me, it
Okay.
is very
Okay.
easy. If you see the place, if I do Alexa list, it is not visible on the screen. Yeah, so I have used, there is a Linux containers on which I have hosted this. Like we have a Django on top of it, and then so many things. This is this particular container. If you can see, right, Charm Kit. Maybe it is visible later. So it has Docker on top of it. If you can see two Ethernets, right? So it has Docker on top of it, and then I have added this as a node.
Okay. Okay.
Yeah. So you know, right, where to check
So
the nodes for. Yeah.
so you did not configure the Docker cloud again in the Jenkins, right?
No.
In
So
the
didn't do that. I think so. That could be another good use case. I just wanted to have something bare minimal running, and then we'll start putting up something, and then they start enhancing it.
Got it. Got it. So everything Docker and all installed in Django node itself, right?
Yeah. So that the node which I showed you, right? So the Charm Kit, it's a
Yeah.
Ubuntu 16.04 machine, and on top of it, it's container, and on top of it there is another container that's a Docker container. So since it is very easy to bring up, I have used that, and then I have connected it to my Jenkins.
Got it. Got it. Okay, fine.
So till then, I can show you the notes maybe. Any other questions? I mean, if anybody has any other questions. So Prajwal, this is where I have configured. I have added that node over here.
Okay. Okay. So here you have given the IP what it is showing in the
Yeah, yeah.
under
So maybe I can
right?
show you from here. Yes, yes, I'll show
Okay.
you. So there are 2-3 ways how you can actually add node. So there are like, so in this case, if you can see, right, so it is the same IP, and I have done public key private key configurations which directly in talks to each other, and then I have added this agent on that machine. So if you check this IP, it's the same ending with 121. This is the Ethernet IP.
Fine. Fine. Fine.
Yeah.
Cool, dude.
Yeah, another thing is that I didn't add webhook, because when you add a webhook, you can directly do it. Or in this case, instead of adding webhook, so as I said, right, so you have nightly builds use case. So there is no need of actually running your builds again and again, because if there are so many people working on it, and then the manager says that, okay, today this is the timeline before it, please submit all your PRs, and then after this the build runs. So for this use case, I don't think so we need it. Yeah, so we have this successful. Ideally we should get one more version of a code over here. So it is directly related from here. If you see, right, so if you can see, there are 2 stable builds with this is the, I'm deleting the one, this is the 5th build, and I should have 2 images like master_4 and master_5. I mean, you can use any other variable. For example, if you see, right, so you have 2 builds, you can use any other variable which you feel like that is unique, and it can help you to identify which is stable or not. And then after this, you can pass this image to any of your colleague or maybe to QA team, so that, I mean, for devs testing, they can actually help test it and then say that, okay, this particular, then you can trigger an email to them and then say that, okay, when you approve, then this particular image becomes underscore stable. Then we can pass it to different stages. So I was just trying to make it as simple as possible. Yeah. So guys, please fork this repo, and then if you want to add anything, add it. If you want to raise a PR, and then maybe we can have something more. And there are a few more repos here, which I think it is like you can go ahead. So there is this something called osgroup-techies. So in this, I have written the Terraform for my application, and also there are different roles. There are Ansible roles, so you can try it out. Some of them are production ready, and some of them are dev ready. So please use that on your own risk, because there's like, we have in development, but it is like very slow development on this. Yeah. So you just clone this repo. Maybe for Terraform stuff, you don't need to clone this repo. You just go ahead and clone this one. Clone this one, and then go to Terraform. And then, so I have been working on LXD and Docker as a provider. So I have two set of folders over here. You can go ahead and check this out, check this folder out, CI demo. And in this, when you clone it, you just pass the different version. So when you see, if you feel like you did some change and you wanted to push it, you wanted to test it with this, you just change the image name. So that is, sorry, that is here. Yeah, here. You just change the image name in this file. And then if you have already running one particular version of an image, when you do Terraform apply, it will just create a new image and later delete the older one. And then you can do something like that. Yeah. Sorry, yes. I thought somebody had question. Okay, so this is what I think I have. Maybe if you guys have any questions in any part, so we can go ahead and discuss. Till then, I can actually show you how to, like for example, you have cloned that repo DevOps for you, and then how you get your application up and running. Maybe you can just go to Terraform, Docker, and CI demo, and then you do Terraform init. So all it is doing is, yeah, so it will be like going and cloning the code from another repo, which is osgroup-techies, and then it will just, when you do Terraform plan. Sorry, there is some issue over here. Maybe I can go ahead and fix it. Okay, there is mount path. Okay. So this is one way to get it done. Okay, maybe I can fix it later. This is permission issue. Yeah, this can be fixed. Yeah, so when you do Terraform plan, you could see what it is doing. It is creating a Docker container, and then it is exposing your internal 808, external 8080 to 8080. This is where how it maps. So whatever IP, whatever port you put in the file, you can just go ahead and just use it like localhost and that particular port as I've used here. For example, here 8080 and then /meets, because there is an application called meets. And if you do /admin, you can actually access the admin page, but in this case, it is protected by password. Only I can access it, but I think so you can go ahead and access this and then make some changes in the logic, how this particular columns are coming. So I'm facing one problem that I'm not getting this all in. Because I wanted 3 columns at a time, but that's I'm not getting. Maybe if anybody has some logic, they can suggest. Yeah, so this is all I got. Now time for QA. So I'm not applying it because it is like I am out of resource. So, and I also will push this change. So I use this. Yeah, so it's not suggested to push it directly to the master. So since I'm the owner, that I'm pushing it to the master. So usually you have a different branching technology. For example, you can branching methodology. You can have one for dev. Hello, mic check. Yeah, so you can have different branch. You can have restrictions on that branches. Maybe, so for example, you don't allow people to push it to that branches. They can only be merged via PRs. And then, as Sumit said, that you have their own branch. You make your changes and create a PR. And maybe you can have, if you have so many changes, frequent changes, you can stash all the commits and make present as a one commit, and then so that it becomes very easy for a manager or a reviewer to review it and then merge it. And then you have your nightly builds. Yeah. So I'm not showing anything on CD part. And if you want to try out this application, you can just go ahead and do Docker run and -d -p. You can use that. I mean, you can get the documentation on that. And also, if you don't want to have that pain, you can just do Terraform init and Terraform apply. So that will get you this application running, and then you can actually change the code. And if you have your own Jenkins, you can actually push it. And then if you want to push it to my repo, maybe I can give you the token. And if not, if you want to try it on your own, you can try it on your own. So I think I am. This is all I have. Maybe if you guys have any questions, or Sumit or Prachul or anybody.
No, Shailesh.
Okay. So anybody else? Just give me a moment. I got a call. So if not, I think we can have a quick feedback. Maybe Sumit, you can over to you. Maybe you can take this and then ask people if they have feedback, and then we can close.
Yeah. So yeah, thanks a lot, guys, for joining. I have put some poll questions on the chat itself. Please take some time. And yeah, anyway, if you're connected to our WhatsApp group or here, or as you saw our GitHub handles and whatnot, so we can connect on multiple platform, and you can tell us what you want to talk us about later in the future. And yeah, then thanks for joining, and then we'll see you again on next weekend.
Yeah. So I just wanted to add one more point over here. So in the next session we are thinking of to be on CD, and then we can connect these all dots together. So yeah, and we also we also accept, like, for example, if you have any suggestions or if you have anything to present, we can actually use this platform so that it becomes very easy for us to learn. So let's make it two-way, or yeah. So yeah, that's all I got. And please, guys, if there is a poll question, maybe you can actually fill it, and then it will give us a more insight what it actually, what direction we should go, and whether that the pace we went is correct or the technology we took is correct or not. Yeah. So maybe Prajol, if you want to conclude something, and if you say something, and then we end this, and then we have this recording today. Maybe we can share it with you guys over email or maybe on the YouTube.